as you can see, we're going to talk about 1's complement and 2's complement, and these are ways of dealing with negative numbers in binary. Now, we've already looked at some negative numbers in binary. We've looked at sign and magnitude, and with sign and magnitude, all you have is the first bit represents the sign, so it's minus, and the second bit represents the magnitude, as well as the second bit, sorry, the second section, everything else represents the magnitude or the size, so in this case that's minus 3. And that's fine, that's okay, but there are different ways of doing it, and the reason there's a different way of doing it is this. Let's draw a number line. Let's pretend we're in primary school. Let's pretend I can draw a minus sign. Number line, minus 7 to plus 7, that's the range of a 4-digit signed binary number, okay? And we're going from minus 7 to plus 7. The problem we've got is, say I've got plus 6. Plus 6 is this. Okay? 4 and a 2. If I want minus 6, I just change the sign. So that's minus 6. Okay? So there's my minus 6 on the number line. Now in deanery, in mathematics, if I've got minus 6, to do a little kind of aside up here, minus 6 plus 1 equals minus 5. Hopefully you'd all agree with me on that one. Okay? So I think that minus 6 plus 1 should be minus 5. So if I add 1, that's fairly straightforward. And then what's that? Well, the sign is negative, and the magnitude is 7. So minus 6 plus 1 is minus 7. It doesn't work. The numbers from 0 go backwards, because what we're doing is we're counting from 0 with sign and magnitude. We're saying 0 means it's positive, so we start from 0 and go to the right. And then this is how far we go to the right. We've got 6 spaces to the right. Okay? With negative, we start from 0 and go 6 spaces to the left. So if you're negative numbers, your mathematics is reversed. And it's not the end of the world, it's not impossible to deal with, but it is problematic and it's a bit awkward. Okay? So that's why sign and magnitude isn't the only way to do negative numbers. Some people really like it, some people don't. There are other ways. And what people decided to do was use something called 1's complement. Okay, 1's complement. There we go. And what you do in 1's complement, let's go back to our plus 6. Instead of just flipping this bit to represent the sign, you flip everything. So this is plus 6, this is minus 6. Okay? And the advantage now, because we've flipped everything, is instead of saying this is how far we are from 0 and this is how far we are from 0, we're saying this is how far we are to the right of our number line. So here we've got 0, 1, 1, 0, which is 6. Here we'd have 0, 1, 1, 1, which is 7, and that's going in the right direction. 0, 1, 0, 1. Okay, we can see adding 1 sends us in the right direction. Here we've got minus 6. If we add 1 to minus 6, that gives us minus 5. Okay, which is heading in the right direction. We're adding bits and we're heading this way, which is what you're supposed to do when you add. You go to the right. Okay, now to prove this is minus 5, using 1's complement, we just flip it. And that's 5. Okay, so that must be minus 5. Yeah? You just flip the bits. Now actually we don't use 1's complement very much, so don't get too carried away with this mechanism just yet. We're just seeing why the flipping the bits works, because it means everything goes to the right when you add it, which is great. The problem you've got with 1's complement is if I've got minus 1, which is this, sorry, minus 0 I should, no, minus 1, sorry, I'll do it the right way around. I've got minus 1, so normal 1 is this, so minus 1 is this, okay? If I add 1 to it, I should get 0. And that's actually minus 0. So if we flipped it, it'll be zeros. If we add 1 again, we get plus 0. If we add 1 again, we get plus 1. Now the problem is, there's twofold here. One is we've got 2 representations for 0, which I don't want. And the other problem is that if I want to get from minus 1 to plus 1, I have to add 3, which doesn't, that's not right. If I've got minus 1 and I add 2, I should have plus 1. Here, if I've got minus 1 and I add 2, I have 0. And so we have to build in extra complexity because it doesn't work. There's this error in the middle. So what we do instead is we use something called 2's complement. And 2's complement works in exactly the same way. Let's take our 6 again. We flip all the bits and we add 1. and that represents minus 6. Okay, you flip the bits, you add 1. And what that does is it solves the problem, because if we've got our minus 1, our plus 1 is this. So our minus 1 is flip the bits and add 1. And then if we add 1 to that number, ignore the overflow, we get 0. And if we add 1 to that number, we get plus 1. And that works. Okay. What it does do, though, is it slightly unbalances the range of numbers. Because, okay, if we go minus 7 to plus 7 on our number line for the last time, okay, we've got 0, 0, 0, 0 in the middle, up to 0, 1, 1, 1, yep, which is plus 7 at this end. If we want to do the negative versions, if we want to do negative 6, for example, there again is our 6 plus 6. So 2's complement, invert it, add 1. Can't add up in binary, there we go. That there is our minus 6. Minus 7, we do the same thing. Invert them, add 1. Get confused how I write this, hold on. There we go, so there's minus 6, there's minus 7. What we can see is we've got 1, 0, 1, 0. If you ignore the sign, 0, 1, 0, 0, 0, 1, we should have 1, 0, 0, 0. And we do. That's minus 8. Okay? So what we've actually done with 2's complement, because we had a plus 0 and a minus 0, we've got rid of that. We've got an extra number we can use. And the extra number is minus 8. We stick it on the minus side. The reason we stick it on the minus side is the number we've got rid of is the negative 0. Yep, because positive 0 we just represent like that, which is regarded as positive because the sign is 0. And so we've got rid of minus 0, so we stick on a minus 8 instead. The rule, if you can remember it, is as simple as take your positive number, flip it, add 1. Okay, so this is plus 3, this is minus 3 in 2's complement. Okay, obviously 1's complement is different, sign and magnitude is different. You've got to be aware what method you're using, but that's how you do it. Okay, if you want to take, if you get given a negative number, what you can do is take 1 and then flip it, do the reverse. Okay, and so that would be minus 3, that would be plus 3. Okay, I know it's minus, it starts with a 1, and the 3 I get by taking 1 and flipping. I do the opposite process. Okay, so let's say I wanted to make a bigger number, let's say plus 142. Can I do 142? No, I can't. Let's do plus 112, because I can do that one. Okay, plus 112, that's easy. The first bit's a sign, it's positive. A 64 and a 32 would give me 96. A 16 would give me 112. Is that right? 96, 106, 112, yes. So I think that's plus 112. If I want minus 112, what I've got to do is flip all the bits. Ooh, there we go, that's the right number of digits, that's better. Flip all the bits and then add 1. So add 1, that would go 0, 0, 0, 0, 1. Okay, and that there would be minus 112. So even with big numbers, it's just the same. You flip and add 1 to turn it into a negative number. If you want to turn it back into a positive number, let's say we've got this number here. You take 1 first, and then you flip it. And we've got, is that 32? No, 64. And a 3, so that's 67. So that's plus 67, that's minus 67. And there's our 2's complement. Okay? So the way to think of it is in your number line. I know I said it would be the last number line, but I said it was the last number line between minus 7 and plus 7. Now it's between minus 8 and plus 8. Here, we're talking about the sign is 0, and the magnitude is the distance from 0, the distance to the right from here. Here, we're starting from a negative number, and it's the smallest negative number, it's the furthest left that we can get. If we add 1 to it, or we add lots to it, this is the largest negative number. This is the largest number we can get that's still negative. Okay, so its distance from the left is the magnitude here. Okay, and the basic rule is if you're converting positive to negative, flip the bits and add 1, negative to positive, subtract 1, and then flip the bits. And that's 2's complement. Best way to practice any kind of binary stuff like this, any binary mathematics or binary conversion, simplest thing to do is just make up some numbers, just whatever numbers they happen to be, and work out what they are and do some exercises. So if I want to work out what that is, I would subtract 1 and flip it, and then that would give me, that's, did I do that previous one wrong before? That's definitely 64 anyway. 64 and 10 and 11, so that'd be 75. Okay, so that's plus 75, so that one there is minus 75. Leave the working out to show how you've done it on an exam paper, but that number there is minus 75, that one's plus 75, and all I'm doing is just making up strings of 1s and 0s and converting them. So it's dead easy to practice.